Hello. So welcome to this daily question. This daily questions is 3658 GCD of odd and even sum. So let me read the question. You are given an integer n and your task is to compute the GCD of two values, odd sum and even sum. Odd sum, the sum of the smallest n positive odd numbers and sum of the smallest n positive even numbers. Return the GCD of both of it. This is the example given here. Let us analyze the example. The example given here is n equal to 4. So first four number of odd and first four number of even. We have 16, we have 20. So we will find the GCD of 16 and 20, which is 4. So let us now understand what is GCD. So GCD is greatest common divisor. So as we have two numbers, we have 16 and 20, we need to find the greatest number that can divide both. This is the proper definition as the largest number that divide both of the number exactly. Now let me see the example. As here we have 12 and 18. So we will write the factor of 12, which is these till 12, and the factor of 18, which is this, and till 18. So finding the greatest integer that is common in both. So we can say as 6 is the greatest integer that is common in both. So we have the common factors. So these are the common factors in both. This is the greatest integer. So this is the largest integer. So that is the answer. To calculate the GCD, let us imagine that someone gave you the number 16 and 20 and ask you a simple question to find the greatest number that can divide both. Don't just straightforward jump to the formulas, and let us try to think about the brute force. So in thinking about brute force, ask a question as how can I check whether a number divide both? So this question itself will leads you to the brute force. Let me make you clear how to think about the brute force. Now step 1, to think the brute force as, let us say our goal is to find the biggest x. So we have like 16 divisible by x and 20 divisible by x, which is equals to 0, means this x is the biggest brute force solution we have. Let me directly move you to the dry run. So in dry run, we have two numbers 16 and 20. The answer cannot be larger than these two. So we have its minimum because we have the greatest integer, which will be smaller than these two, because as we have seen in the common factor, the number is smaller than the smaller part of this. So we will find the minimum of it. So we have the minimum. So start checking downward. You have to check from this minimum part. We are going from 16 to down as minimum to down. So is 16 dividing 16 and 16 dividing 20? No. So 16 dividing 16, yes and yeah. So this 16 is not the answer. Now moving to 15 as the 15. So is 16 dividing 15 is equals to not equal to 0. So now moving towards the 14, as it is also not dividing the 0. Now 13 is also not dividing both. Now moving to 12, so 12 is also not dividing both. Now so on, that's 11. So it is not dividing both. Now coming towards 10 is dividing both. So let's check. 10 is dividing both. So 10 divides 20 equal to 0, but it is not equal to 0. So it is a big no that it is not dividing it. So this is not our answer. So after continuing this effect, we will have like 9, 8, 7 type of things. So these are non-working because these are not dividing it. So finally move to 6 is not dividing, and moving to 5 is also not dividing. Now let us move to 4. Coming to 4 is dividing 6, which is equals to 0, and it is also dividing 20, which is equals to 0. So yes, it is dividing both of the numbers. So the largest number is 4. As we can see, this is the loop which is working till minimum of a and b and decreasing one by one. If the I can divide both, I can divide a and I can divide b, we will return the I as soon as possible because we are decreasing from larger to the smaller. We need to stop the thinking as to iterate in all the numbers. We can jump to the most clear number to be the GCD. So most of these numbers are very unuseful because we got the answer at very last, which is 4. This led to the optimizing idea as to think about to decrease the number of iterations. Now start the observation that how can we reduce the number of steps. So taking 16 and 20, let's subtract them. After subtracting 20 and 16, we have 4. Interesting, right? Now check, as the GCD of 16 and 20 is 4, but also the GCD of 16 and 4, which is coming by subtraction, is still 4. Why this? Why this is happening? That the decreased answer is also giving us answer. So why it is happening? So you got the answer of why, as it is a hurt of Euclidean algorithm, that suppose if we are having a number d which can divide both, so let us d divide the 16 and d divide the 20. Then if d also divides 20 minus 4, let us not take that. If you can understand that, if there is a number 16 and 20, d divides it, and d also divides the 20, and let us say there is something. So now there is an example that we can take d equal to 4, as if we are taking d equal to 4, then there is 4 and 4, and we have these factors, the something, we can replace it with this. So as you can see, there are 4 is hidden inside this. So how to find this part and how to find the valid answer from this part? To find the 4, let us visualize that as 20 have the boxes and 16 have the boxes. Let us boxes have the size of d. The d is 4, as we know from it, as the d is 4. So the d is 4. Now each boxes of d size, we can subtract them as we have. So the common is the 4 boxes that are cancelled, but one box remain. Now one box remain is also divisible by d, because the d is 4 and the divisand is d is also 4. So the remaining, if we subtract both, so the remaining part is also divisible by the thing which is our GCD. So the key observation here is, if the number divides both of the number, then it must divide their difference too, as we have seen that their difference is d, and d is also divisible by the GCD d. As we have seen here, as we have subtracted the number, there is a d extracted, and this d is divisible by the GCD also itself. So we have the observation that if a number divides both number, it must divide their difference too. So why it is useful? Suppose we have the number 20 and 16. So instead of working with 20 and 16, we can replace the number by the difference 4. Now solve the GCD of 16 and 4. The answer does not change, because every common divisor of 20 and 16 will divide 4. Okay, so now the number become much smaller. So we can do smaller things where the GCD will of both numbers will equate. That is the part where we find the GCD. Now let us have a dry run. It will make you clear that we have a question to find the GCD of 48 and 18. So instead of working on these factors, subtract 48 and 18, which is 30. So we will find the GCD of this 30 and the smaller part. Okay, so this 30 and the smaller part. Now again we need to subtract both of them. So we have 12. So we will find the GCD of this smaller and the 12 part. So we have this. Now again we need to subtract it. If we have the 6, now we can find the GCD of 12 and 16. 12 and 6. Now again, if we having the GCD of it, so we can subtract it and get 6 and 6. So now getting the GCD of 6 and 6, which is equal. So this is the part where we got the answer, as answer is 6. Let us have the brute force method. So the brute force, this is the brute force method we have. So we have GCD, and we need to find the sum of first n numbers and sum of first odd n numbers, sum of first even n numbers. So we are finding the sum of first odd and even n numbers. Now let us take the minimum of it and just return the greatest common divisor. Let me run it. After having the run, we can see that these are accepted by these test cases. Now after submitting it, we can see that this question is submitted. So the brute force also works. Let me show you the time complexity of this brute force. So time complexity is n plus, which is calculating for the minimum of, which is calculating the sum of n numbers, and this is to calculate the for loop. So it is roughly around big O of n square. Now let us come to the optimized approach. Which is Euclidean algorithm. To come to the optimized approach, I have written the optimized approach here, as this is to calculate the sum of odd and even numbers. Now call a method which is by sum of odd numbers and sum of even number. We have this, and we are calling the smaller number, and we are calling the bigger number modulo the b, as to calculate the modulo of it. So this is the Euclidean algorithm. Let me run it. It is passing all the test cases. The time complexity of this Euclidean algorithm is n plus log of minimum of this sum of odd and sum of even. There is also a mathematical optimized solution, which is solution is only this, which is come in the mathematical formula, which is this. So